Now we're on to the stem and leaf plot. So what a stem and leaf plot is it's the digits of the leaf place value form the leaves, and the rest of the digits form the stems. So in this case here, the least place value is our ones, and the most place value is our tens. So our stems are going to be our tens place, and it looks like we go from 30 up to 70. So we'll have 3, 40, 50, 60, 70. And then our leaves, we want to kind of make them in order. So I'm going to do my best here. We've got a 32, another 32, we got a 35, 35, another 35. This is why it's important that we're crossing off so I can see what I'm missing. I know 40 is the smallest one that we'll have, so there's a 0, another 0, another 0, and another 0. So there's 4 40s. Then we got a 42, a 43. Oops, look, surprise, I found a 36, so I'll go add that up there. 45, 45, 48, and then I have 2 50s, actually 3 50s, a 61, and a 70. So there's my stem and leaf plot of all of that data. So you've got your tens place and then your ones places. A circle graph is a graph that shows the relationship between parts of the data and the whole. The circle represents all of the data. So you split up your numbers into fractions. Okay, so she spent a total of 8 hours at summer camp. Okay, this is how she separated that 8 hours up. So I'm going to split my pie chart into 8 pieces. So 2, 4, 6, 8. Okay, I've got canoeing. That took up 3 hours. So 3 hours every day she canoed. 1 hour she did crafts. So one of my pie pieces is crafts. She ate for 2. So 2 pieces are eating. And then we'll leave the other 2 for hiking white. So that's a different type of visual representation that you can have there. Here we've got a box and whisker plot, and that's a graphical representation of a 5-number summary of a data set. The box represents the interquartile range. So what you do is you're going to have a number line. Okay, so you're using graph paper to do this, so all of your numbers are equally spread. Mine's not going to be the most perfect thing in the world, but I'm doing my best, and that's all that counts. Okay, so first thing I'm going to do is put my numbers in order here. So 8 is the smallest, 13, 14, cross, cross, 16, I see another 16, 18, there's another 18, 20, 20, 22, and 30. So for my box and whisker plot, the information I need are my minimum, my maximum. So I need the min, max, the lower quartile or quartile 1, the upper quartile or quartile 3, and then the median. So our minimum is 8. Our maximum is 30. Those ones are easy to find. Now I'm going to find my median. So cross, cross, do, 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 do. So my median is 18. When I figure out my upper and lower quartiles, I do not include my median in figuring that out. So my lower quartile, boom, 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 is 14. And my upper quartile, boom, 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 20. So I'm going to make my line graph here, going from 8 to 20. So I'm going to count by twos. We'll start off at 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. Okay, our box in and whisker plot is made up of the left side being the lower quartile and the right side being the upper quartile. So our lower quartile is 14 and our upper quartile is 20. That creates our box. Within our box is the median. So we just draw a line at 18 for our median. Then the whisker parts are reaching out to our minimum and our maximum, just like that. If I asked for a double box and whisker plot, there would be two different sets of data, and you would just graph them one on top of the other. So say we had another set of data that looked something like this. Then you would just graph that way, and there's a double box and whisker plot. So you've got min, lower quartile, median, upper quartile, max. Making sure that it's spread out evenly along a number line. I'm going to skip this slide because that was just me explaining to you what a double box and whisker plot is. And then, which type of graph is the best way to display each set of data? So if we want to know the results of the women's Olympic high jump event from 1972 to 2008, so we know that we want to see what the change in women's high jump is over time. When I'm thinking of seeing change over time, I'm thinking about a line graph. So you can see up, down, up, down. So a line graph, because we want to see change over time. So from 1972 to 2008. If we want to see what percent of students in the class who have 0, 1, 2, 3, or more than 3 pets, I will know that my whole is 100%. We want to see what percent is 0, percent is 1, 2, 3. So when I have a whole, when I'm looking for percentages of things, I want to see that in a circle graph. Because I can split up chunks into percents and see, oh, look, most of the class has 3 pets.